Hello. Oh, that's weird. Oh well. Hello, everyone. My name is Matt Williams. I'm curious. Can you hear me? Before oh, is anyone actually here? Am I talking to the ether? Oh, there. Oh my God! 6 people showed up. Thank you. Can you hear me? Can you hear anything I'm saying? Can you hear the words coming out of my mouth? If you could just send something in the chat, just to let me know that you're hearing it. Oh, perfect. Hello, Tim Deploy. Ploy. Interesting. It's an interesting last name. Where is that from? Where are you from? Hello, Michael. Oh, is that the Michael? Which Michael? There are so many Michaels. Cool. Thank you, Lord. Well, I guess all of you have responded saying that you can hear me. That's good. So yeah, I was there's a few things that are leading me up to this stream. First off, I've got this Ollama course that I've gradually been. Oh, born in South Africa. Interesting. One of my friends, I haven't spoken to him. John, I haven't spoken to in ages. From Cape Town. Although we knew each other when we were both based in Amsterdam, and then then he moved. He left Amsterdam, and I didn't really realize where he went. And then I left that company called OpenText. I moved to Boston, and it turned out he was in Marblehead, just a little bit north of where I was living in Boston. Anyway, so a couple things that led me up to this stream. So I've got this Ollama course where I put out another video kind of in the course every week, every Tuesday. And there are 3 main topic areas that I had just kind of figured out for that course. And I started all on the basic stuff. So basics is the first one. And then comes advanced, and then applied. So basic, is how do you get started with Ollama? Advanced are all the things that are useful to know, but not super critical that you know. If you don't understand how to remove a model or uninstall, it's not the end of the world. In fact, maybe that's good that you don't know how to uninstall. Keep it forever. But and then there was the applied, and I haven't done any of the applied videos yet. But applied was going to be, well, let's look at a UI. And I've done some UI reviews, but let's learn how to use these different UIs. And with the big ones being OpenWeb UI and Misty and a bunch of other Page Assist, maybe, oh God, what's that one that LLM anywhere, anyway, whatever that one is. So there's all those and maybe create 1 or 2 or 3 videos on one of those. But the problem with building on any sort of end user application is they change so quickly. I'm always going to be out of date. But then the other part of applied was just, let's look at models. And what is the best model for you, for whatever you're doing, or what do if there's some brand new model that comes out, what can you do with it? What is really special about that model? And so that was always kind of the intention, but I always had so many other videos to do, all the basics. I think I've got most of the basics covered. But I've got maybe 10 or so of the more advanced topics that I intend to do, and then the rest are all going to be more the applied. And then just a few days ago, I was given a machine. Okay, so back up. Another goal has always been since the beginning of Ollama, since the team of 7 of us at the time started building out Ollama. I always wanted to see kind of a good benchmark, because all the benchmarks suck. No matter which benchmark you look at, it's terrible because it doesn't. They all seem to apply. They all seem to think of, it's all about the answer that the model gives rather than the time it took to generate that answer. And if a answer is 10% better, but it takes 5 hours to complete, well, the one that was 10% less good is probably the better answer because I got it in 10 minutes versus an hour or whatever it is. So that's one of my big beefs with benchmarks. And then also, what are they benchmarking? It's always the full model rather than the quantized version, or the quantized version, which most people are going to use. Are they any good? And how about going from is a Q8 7 billion parameter model, how does that compare to a Q4 30 billion parameter model? And those types of things you can't really see in those benchmarks. And then the benchmarks if the model that you care about is going to be in the benchmark, it was kind of a flip a coin. It's hard, not all the models are covered in the benchmarks. And I'd like to make sure that all the models that Ollama has are covered in a benchmark, and all the different quantizations. And another super critical point is that the benchmark is not open source. So many of these benchmarks are open source, which means the questions are out there. And we've seen already that models will game the system and, make themselves look better because they know the questions ahead of time. And there have been enough examples where that's been shown to be true. And so make a closed sourced benchmark so people don't see what the questions are, and see if that is interesting. I guess that was, I don't know if this is something that would be interesting, but I think it would be. And I wanted to play around with it. But, I've got this M1 Max MacBook Pro with 64 gigs, which is a great machine, but I can't run a 405 billion parameter model on there. And I don't really want to pay for, some host up in the cloud. And so recently, just last week, I was given a machine to play with. I said, do whatever you want with it. It's yours to play with. We'll try to give you a few weeks notice when we need to take it down, but you can have it free. Just do cool stuff. It's like, great. So this machine is, where can I see what it is? So it is, it's a machine up in the cloud. It's got, where can I see how much it's got? RAM is, it looks like it's about 1.8 terabytes of RAM, which is awesome. It's got 8 H100s, 8 H100 GPUs, and about, I thought I increased it, about 10 terabytes of disk space. So massive. 8 H100s, super cool. So now I've got this machine, and I can do anything I want. And so I've already got it to the point where I've started downloading every model from Ollama. I haven't completely done that, but almost every model, with the exception of the 8-bit quantization and FP16 for the four or two different 405 billion parameter models, since I don't think even the 8 H100s will be able to run that. So I don't want that. So those are the four. There's two, so FP16 and 8 for the, is it Llama and then the Hermes Llama model. So I got rid of those four. But every other quantization of every model I'm downloading, and then I'm going to have it run through, and I've got it basically, when it runs the tests, it consumes all 8 GPUs, and they're like 100%. And so going through and asking the same set of questions, a set of questions that I've come up with, and I'm adding more and more to it. Right now it's at probably about 100 questions. And maybe I need to increase that, but let's start with about 100 across all these models. And there's, when you add up all the quantizations, there's about 150 models, but some of those models have 80 tags. So each of those 80 are all being compared. So that's a huge amount of data that I'm kind of going through. And the goal will be to have a few different models kind of assess which answers are the best, but also want to make it available so that the community will be able to assess. Maybe they'll. I think one of the best tools I've seen was how we used to figure out which talks to do when I was one of the organizers for DevOps Days in Seattle, as well as DevOps Days in Boston. And that is, I can't remember which platform it was, but it would show, 3 different abstracts, and you can say, this one is the best, and these two tie for the second best, or it's A, B, C in order of, which ones are the best. And that way we could figure out, for all the organizers, all 4 or 5 of us, would be able to sell, here are the ones that we like the best for this event. And I like that idea, and trying to apply that to grading models as well. So building out the test framework, as well as the thing that is downloading all the model, all that stuff all works, as well as running the tests, all that works. Was pretty amazing because I was able to use Windsurf to code that up, and it works beautifully. And again, it consumes all the GPUs. It's really pretty cool. Let's see, how are we doing? Cool. So that's kind of where I'm going with that. What else do you do with 8 H100s? Not A100s, H100s. Each of those has, it's the NVIDIA has their compute level. It's the highest one. It's their top card. 80 gigs of VRAM each one. So 8 times 80. What's that? 640 gigs of VRAM. 640. Oh my God. I get giddy over thinking about this. So as I say, I have this for at least a few. Could be a month, 2 months, 3 months, forever. I don't know. But as long as I have it, I'm trying to consume as much of the power as I can. But anyway, so let's take a look at. I don't want to show that. I'm going to close this. Close this and close. Do you have a reference Docker image with all the AI tools? No, I don't. All the AI tools I don't know if there. I mean, there's too many AI tools. There's a lot of cool. I mean, I guess you could say that my favorite AI tool is Ollama, but I use it on a Mac, and so I'm not going to use Ollama in Docker on the Mac because Docker on the Mac doesn't have access to the GPU. So, but then again, I now have this big box. Maybe now I don't. No, I haven't. The tools that I use in this stream, I'm going to use OpenWebUI, and that's a pretty cool tool. That's already in a Docker. It's already available via Docker. And the other one that I really like now is called Invoke AI. It's a text to image generation tool. Let's see, let me close a bunch of these tabs in my web browser, and then I'm going to share my web browser. It sounds like my dog is trying to get into my... Hi! Oh, what's up? I'm taking to what? Oh, okay. Sounds good. Bye. Yeah, so let's close out some more tabs. Okay. So, I'll show this screen. So yeah, on Ollama, just in the last, let's close that out. 6 days ago, there was ExaOne3.5, a instruction-tuned bilingual English-Korean generative model ranging from 2.4 to 32 billion. So 2.4 billion, 7.8 billion, and 32 billion parameters. And, that shows a benchmark. Yeah. What do you need? What's going on? Okay. I have a screaming child. Anyway, so it looks like it performs well compared to other models. And whenever, so this is one of the problems with benchmarks or with the benchmark grid that different models will show in their I'm hearing screaming in their kind of about page. Is that okay? Well, this is how it compares to these 3-4 models. I kind of wish they would show others. I'd like to know how it compares to whatever model I know about. But we never see that because there's never enough room. It's just a HTML page or just an image. So yeah, I've got all sorts of problems with benchmarks. But yeah, so I thought we'd just take a look at this. What do you think? Everybody good with that? Oh, hey Matt, what's your take on agentic frameworks? Which do you believe to be more suitable for Ollama use with less bottleneck regarding concurrency? I haven't really dealt a lot with agentic frameworks. I spent a bit of time with, what's that one that some folks seem to love? They got a lot of, God, what is that one? There's one that's super popular. I never understood why it was super popular. It didn't really seem to offer much value and required a lot of Crew. Thank you, Crew AI. That one. But that was months ago, and my hope was that they would, it was super early and raw, and not that useful. And I was hoping it would get better over time. And maybe they have. I don't know. But there's lots of others out there. I haven't dealt with it. It's something I'd like to look into more, but I just haven't. I know nothing. Hello, William Charles. So anyway, let's open up my Open Web UI. So here I go. Here's Open Web UI, and you can see I've got a few models loaded. And yeah, I just keep scrolling. I'm gonna keep scrolling, keep scrolling, keep scrolling, keep scrolling. Oh, there we go. Okay, so a lot of llamas, a lot of mistrals, a lot of gemmas. But what I really want to find is this ExaOne. And I guess let's go with FP16. Sure. And I've got a few questions that I've kind of put together. Let's move this over here. And that way I've got this. And this first one is pretty interesting. And if anybody has any questions as I go along, let me know. We're about 20 minutes in. My goal is maybe do this for an hour. I've got a whole bunch of questions, and we'll just keep trying them, see how they go. This first one is about time travel. So 3 time travelers arrive in different centuries. We know that Alice arrives before Bob. Bob arrives before the Industrial Revolution. Charlie arrives after Bob, but before Alice. What's the correct order of their arrivals? Which is kind of interesting. And press enter, and let's see how this does. Oh, wow, that's... I don't have a way of showing how my different GPUs are running. Maybe I should have chosen a smaller model to begin with, so we're not all sitting here just twiddling our thumbs. But anyway, the goal here, I don't know why the question even mentions the Industrial Revolution, since none of the rest have that. Would love to say, but got to bounce. Thanks, Matt. All right. Well, thank you, Tim, for joining me for a little bit. All right. And let's see. Let me open up my... I don't have the right tools on this machine to be able to SSH into that box. Well, that was a bit silly. Can I do this? Browse. Okay. Browse. Yes. Let's switch that out to there. Firm. That. Now I can... Not found. Did you hear about the new 5.4 release? I did not. Okay, so I can't find this machine. What account am I? Oh, I set my organization. Ah, okay. Org set evangelist. No evangelist. And now shell into that box. It's on Ollama, but still not fully released. Interesting. 14B model. All right, let's get this back online. It's still not loaded. This is really odd. I wonder if one of my big tests is still running, which is totally possible. While I wait for that, let's open up Ollama. It said 554. Oh, okay, so it's here. Is that it? A few different versions. Oh, updated yesterday. Already at 2,300 pulls. That's pretty cool. By -4. Okay, so that's definitely the more popular one. Why is this machine is all of a sudden super slow? This is a badass machine, and it's running very slowly. What is going on here? How about if I ever just refresh the screen? Okay, and can I go up? I don't have my usual clipboard manager on here. Okay, let's copy that and paste that. There we go. Okay, so it says that Charlie arrives before Bob, who arrives before Alice. The problem with this is that Alice arrives before Bob, and the problem is that the question there is no right answer because Alice would be first and last, and it looks like it didn't capture that. All right. Oops, I don't want that. Why is that going? Let's close. What is going on here? Great. And let's try a different one. Oh yeah, this was pretty cool. Come up with a good seating arrangement. Ethics committee has 5 members. We know philosopher must sit next to the engineer, ethicist can't sit next to the lawyer, data scientist must sit at one end, a lawyer must sit next to the data scientist, determine a valid seating arrangement. So we're going to label them as P, E, T, L, and D. We've given the constraints. Given those constraints, let's find a valid arrangement. And since we know the data scientist must be at one end, it can either be the first seat or the last seat. And so if in either of those, L needs to be right next to him. And so it starts going through all the possible options, and it ends up with PETLD. I wish it would spell out which ones each. Is it obvious? Okay, ethicist is a T, and okay, everything else should be obvious. And let's see, where's my... Okay, philosopher must sit next to... philosopher must sit next to the engineer. Check. Ethicist can't sit next to the lawyer, which T is next to the lawyer. Okay, so I did this once earlier, and it like nailed it. It got it perfectly right. What happens if we try it again? Can I send this again? See if it comes up with the right answer this time. Some people are annoyed when a model will come up with different answers each time. But that's how these things work. So you kind of have to look at what's the average answer over 10 tries in order to get something that's always, or that's to see whether the model tends to get it right or not. Well, this is really going into it. So one concrete example. Final or valid arrangements. Okay, so data scientist, lawyer, ethicist. Wait, we know that the ethicist can't sit next to the lawyer, so it fails there. Okay, so here we've got, so philosopher must sit next to the engineer. I guess PE is philosopher. What do we have? No. Who's PE? Oh, P and then E. That's confusing. Thanks. It's just totally gotten confused. It's confusing me. There is no PE. There's P and there's E, but now it's jumbling them up. And so it's totally confused. Okay, so I would say that failed that. Let's move this view up here so I can see who's. Okay. Yeah, I'd say that that got both of these wrong. Let's look around for something a little bit different. How about this? Copy this and paste this in here. A city replaces all traditional light bulbs with LED bulbs, but overall energy usage increases. Explain the possible chain of events leading to this outcome. Where did I come up with my answer here? Okay, so here's a possible chain of events explaining increased energy usage despite switching to LED bulbs. So it's more efficient per unit of light, but maybe now, because they're consuming less power, homes, businesses, and public spaces can install more lights, or lower operating costs means that they leave them on longer. I know that we have LEDs throughout our house. I think seem to remember there's like 200 LED, these pendant lights. And our main living room, there must be, well, just in the dining room, there's probably 9, 12. And then another, yeah, so there's about 180 to 200 of these lamps. I think there's 200 total devices, but that includes all the shades, all of these shades as well, which are all on the same Lutron system. So, and I know that there are some lights that we keep on. I mean, they're all kind of automated using Home Assistant, but they are. There's some lights that stay on all the time, or pretty close to all the time, and our bill is super low when we don't use the heat. Then the power goes up. All right. While LEDs are efficient, dimming them can further reduce energy use. However, if dimming practices don't adapt, or if dimming technology isn't widely adopted, LEDs might be left at full brightness more often than traditional bulbs might have been dimmed. Okay. LEDs enable new lighting applications previously impractical due to cost or heat generation. This could include outdoor lighting. Yeah. I mean, we're coming up into Christmas, and I think I've seen far more lit up gardens and houses with Christmas lights because of their LED lights and lower power requirements. Lifestyle changes. Even subconsciously, perception of LED lights as always on friendly might influence behavior. So while LEDs do save energy, overall increase probably arises from behavioral changes, increased lighting density, and adoption of new lighting applications. So that's a good, nice, interesting discussion of why energy usage increased. How about this one? A local coffee shop starts offering unlimited free refills. Describe all the potential ripple effects that could have on customer behavior, shop economics, local competition, and community dynamics. And this is churning out some good stuff. Okay, so what do we have here? Increased frequency. So the thing was unlimited free refills. Knowing that they can get free refills, people might come more often. They'll stay longer and get more of those free refills. How many free cups of coffee can you handle before you blow up? I don't know. Bulk consumptions might consume more coffee than usual. Customers might start comparing the shop favorably with. So all this is good stuff. Shop economics, increased costs because they're going through more of all the base resources. Unlimited increased visits might boost overall revenue. Cost of providing unlimited refills could offset these gains. Operational strain, more frequent restocking, might have to adjust prices. And because of all these extra people, need extra staffing. So, okay, so this is pretty interesting. A lot of detail in here, which is really interesting. What happens if we change this to, we're on ExaOne 32B FP16. If we change to 32B Q4, how is the answer different? Let's paste that one in. It's going to take a little bit of time to load up the model again, which I'm kind of surprised how long it takes to load up these models. I guess I shouldn't be surprised, but I'm surprised. I don't know. That's one of the things that you get. Oh, okay, here we go. So 32B 4K Q4, it seems to do, it looks pretty much the same answer. As what we saw here. Yeah, in fact, should I change oh, what's this? Add model. What do we do here? It's been a while since I played around with this. If I do that, paste this in here, what happens? Oh, we're getting both. Oh, that's a nice way of comparing the two. Okay, so the Q4 on the left side versus the FP16 on the right side. Is it just the formatting that makes it look like there's more on this side? Social. No, it looks like the Q4, like just at a high level, looks like it's going into more detail than the FP16 is, which is amazing. Bizarre. Let's try, since I can add a model, ExaOne. And there's a 2.4. Let's try that at the smallest. And paste in the same question. Okay, so we've got Q4. I should have done this in a different order, but well, I wonder if we are sharing the same GPU. Is this doing something weird like that? Okay. Okay, and then the one on the right side is 2.4 Q4. You know, they all seem to be doing... So you get a little bit more detail with... Wait, are my columns resetting a bit? Yeah, they seem comparable. Let's go down to the bottom, and I think I can see my... Okay, this is the FP16. It's spitting it out in 24 tokens per second response. This is 64 tokens per second. That's the 32 Q4. And this one down here is at 240 tokens per second. Start a new chat to clear history. Okay, sure, we can do that. New chat. Okay, so, and let's get them in order. I'm going to get rid of this one, get rid of this one. I'm going to change this one to be ExaOne. Let's go with the FP16. And then we'll set a new one being the ExaOne. Let's go with the 7. 7 be also the FP16? Sure. And then just because it's funny, we'll go with the ExaOne. 2.4. Well, let's do all FP16s. And now, if I paste in that same question, now the 2.4 FP16 has to load up. I think as well as the 7.8. Have either of these started? Not yet. Okay, 2.4 is starting. This one still hasn't started yet. Still loading. But so the smallest model, that 170 tokens per second. Again, this is an H100. And this one is at 25 tokens per second. Oh, I'm still waiting for my SSH connection to be available. This is weird. And this one was at 94 tokens per second. So it requires a little bit more time to actually kind of go through and analyze which one is actually better. You know, just looking at length isn't Maybe it's more condensed and just better arguments about one versus the other. But it's interesting. And what was the one that we had wrong? A nice one to assess is the ethics committee. Let's give that question a try again. On all three of these. So right away, this over here, we have, okay, philosopher must sit next to the engineer. Philosopher next to engineer. Ethicist can't be next to the lawyer. Nope, he's not. Data scientist must be at one end. Yep. Lawyer must be next to the data scientist. Yep. So arrangement one on the smallest model that, we saw the 32 billion model at FP16, tried it twice. There might have been a third one, at least twice, and it got it wrong every time. The first time I'm trying the 2.4 billion parameter model, and it got it right. How about let's look at this other one. Okay, so philosopher must sit next to the engineer. Okay, so this one it got wrong. And arrangement 2 is wrong. But arrangement 1, that's right. That's pretty cool. I think that arrangement 2 is also correct, even though it's not. And then this one is, so it's data scientist, lawyer, engineer, philosopher. Oh, no, ethicist, philosopher, engineer. And I think that's wrong. So philosopher must be next to the engineer. Oh, yeah, that's right. Ethicist can't sit next to the lawyer. Oh, that's wrong. Okay, so that one's wrong. But this one, ethicist can't be next to the lawyer, right? Philosopher must be next to the engineer. Yep. Data scientist must be at the end. And lawyer must. So in both the 7.8 and the 2.4 got one wrong and one right, which is interesting. How did this one do? So the final arrangement in the 32B one, philosopher must sit next to the engineer. Correct. Ethicist can't sit next to the lawyer. Correct. Data scientist must be at an end. Yes. And lawyer must be, yes. Okay, so in this time, the 32 billion parameter model offered one final arrangement, and it was correct. So they all provided one correct one, but the two smaller models also provided one bad one. Interesting. I don't think anything could be. I don't think this answer is definitive in any way, because the 32 billion parameter model got it wrong twice before. Anyway, so that's interesting. How is it? Is this interesting to you? I mean, I guess like the answer to that question will determine. Oh, there's 34 of you still here, so I guess this must be somewhat interesting to you, or I'm just on your TV and you're cleaning your house. That's a possibility. All right, let's see. What else do we have? Oh, here's. What do you think the ideal solution for changing output from LLMs if we need to use it in business cases? Oh, so the question is, so we know that there's no way to guarantee that the answer from an LLM is always going to be consistent across multiple answers. And is that a bad thing? I think it's still generally a good thing. I mean, I think we still have a long way to go for having models that, I mean, they should always be different, but should end up with the same answer. It can say it in different ways, but as long as it comes up with the same right answer, just in a different format, that should be okay. But we're still not there yet. The folks that will say like AGI next year, it's just ridiculous. I mean, based on where we are today, even on uh, on Claude, on OpenAI, you ask the same question 5 times, 10 times, you're going to get 10, maybe 8 different answers over and over again. So this is not an open source versus big, massive machine kind of problem. This is the way things are. And so I think there's a long way to get to AGI, whatever AGI means to you. It's not going to be 2025. It's going to be one of the estimates, one of the interviews that Sam Altman had 6 months ago or so, said that it was a few thousand days before we get to AGI. And that could mean, if a few is, I thought of a few as, less than 9 or 9 or less. And so 9,000 days, that comes up to, pretty close to 30 years. And I think that's a pretty good estimate. Yeah, I think within 20 to 30 years, we should hit that. Assuming that things continue to accelerate the way that they've been accelerating so far. But yeah. All right. What's the solution? If it depends. Don't use it in places where you need to have the same answer every single time. If you need the same answer every single time, an LLM is the wrong tool for the job. Maybe instead, if people are asking the same questions over and over again, well, ask a question, wait for the right answer or a nicely worded answer, shove that into a database so that the next time a real customer asks, they just get it from the database rather than from an LLM. It doesn't need to be and plus coming from a database is going to be, responding in fractions of a second versus an LLM that's going to be responding, in multiple seconds. Does decreasing temperature increase No. Setting the seed to a specific number will ensure that you get the same answer every time from that question. But setting the seed to one particular number means you might get the right answer for this question, but for this other question, maybe it's the wrong answer. So that's not really a great solution either. There isn't, if you need to guarantee that the correct answer that the LLM gives out one time, it's always going to be correct every other time as well, then LLMs are not the solution for you, at least not yet. Maybe in another 5 years, as the technology progresses, as the technology matures, maybe it will become something that can be used in more of those situations. But if that's the constraint, it's not there. That doesn't mean I don't love this stuff. I mean, this is all I do. So, yeah. Let's see. What other cool questions do we have? Okay, here we go. There's another, there is no right answer kind of question. Compare the internet to a living ecosystem. Explain how websites are like species, users are like resources, viruses relate to biological viruses, and evolution occurs in both systems. I'm shocked I came up with such a good question. I know it's been a while. It's been over 5 minutes since that last question, so maybe it's going to take a while to load up. Oh yeah, I came up with a couple of other good ones. There we go. There's the first one. Comparing the internet to a living ecosystem provides a compelling analogy that highlights both the structural similarities and dynamic processes across vastly different domains. Here's how each element of this comparison aligns. Organisms within ecosystems are akin to websites. Just as ecosystems support a wide variety of species, each occupying specific niches, websites cater to diverse functions and audiences. Each website can be seen as specialized, whether it serves educational purposes, commerce, entertainment, or informational content. Websites interact through links, redirects, and content exchanges, much like species interact through predation, symbiosis, competition, and migration within ecosystems. These interactions shape the web's architecture and content evolution. That's pretty cool. Let's see, what else we got? Resources within ecosystems are analogous to users interacting with websites. Users provide energy flow through interactions like clicks, shares, comments, and subscriptions. They drive traffic and engagement, much like nutrients flow through food chains sustaining life. This is the 2.4 billion model. This is awesome. Viruses are analogous to biological viruses within ecosystems. Computer viruses spread rapidly through networks by infecting other websites or systems, akin to how biological viruses propagate through host organisms via infections. Each viral infection can replicate itself or modify host behavior to spread further. Well, yeah, I mean, it makes sense that viruses are analogous to biological viruses because that's why they were called viruses. Because of the analogy to biological viruses. Is it viruses or is it viri? No, it's viruses, right? Anyway, so this is good stuff. What does the 32 billion parameter one say? So looking at the first one, just as biological ecosystems have a wide variety of species, each adapted to specific niches. Oh, it's very similar. We're using that specific niches. You don't often see that phrase, or I mean, I guess YouTube channels have a niche, but I don't typically see the word niche in a lot of stuff I read. Some websites specialize in news like BBC or CNN, others in social interaction like Facebook or Twitter. There is no site called Twitter, it's X, but whatever. And others in commerce like Amazon or Etsy. Each website, like a species, has evolved to fulfill its particular roles and attract specific user behaviors. Cool. So all these, I mean, this is pretty neat. Oh, what's this? Yeah. I'm finding it very interesting how similar all three models are in their answers, but how the 32 billion parameter model seems to be saying roughly the same things, just in a shorter amount of space. You know, I used to get in trouble. Sort of trouble in first grade. In fact, my mother was just telling my wife this story just the other day. I would get in trouble because we would have this extra. You know, you're learning to write, and you're having to copy what's on the board and write it down on your piece of paper, and everybody else copied exactly what was on the board. They had, you know, and everybody's stuff showed up on their piece of paper was roughly the same length. But mine was about half the size of everyone else. But I said all the same things. I said it, I just condensed it. I made it. So is that smarter because I was able to condense the same stuff into a smaller amount of space? Or is that just me bucking the system and saying, I don't want to do this? All right, so let's see what else. Here's another one that's similar idea. Maybe a little bit repetitive. Oh, should I do another new chat? Compare a national economy to the human body. Map currency flow to blood circulation, government to the brain, industries to organs, economic health to physical health. So currency flow to blood circulation. Money constantly circulates through markets, businesses, and households, fueling economic activities like production, consumption, and investment. Blood delivers oxygen, nutrients, and removes waste throughout the body, sustaining vital functions. Oh, that's how the two compare. Yeah, I mean, all of these they look like they are all good stuff. And it's, again, we see that same, ooh, interesting, a summary map. Basically, saying what we just said. But that's pretty cool. But again, we're seeing the 32 billion parameter model is saying a lot of the same things, just shorter. But doing it in, so total time was about 21 seconds. Versus for this guy, 31 seconds. Well, time, okay, so eval duration was about 4.5 seconds for coming up with the answer. And this one, eval duration was 16 seconds. Yeah. I can ask to create mermaid charts. Yeah, I mean, that's not, is that a mermaid chart? I mean, because wouldn't it be 2 dashes? Or is the number of dashes important? I've always done it with 2 dashes instead of, and I know I've always done it with labels or with A to B and A equals whatever. But I guess you don't have to do that with mermaid. Anyway, so let's see. Let's come up with. I've been going an hour. Let's see if I can come up with a very different. Oh, here's an interesting one. This is also another one of these logic ones, sort of. Okay, in a game show, there are 3 doors. Behind one is a car. Behind the others are goats. After choosing a door, the host opens another door showing a goat. After choosing one door, the host opens another door showing a goat. Should you switch doors? Prove mathematically. I have no idea how to do this. So if it came up with the right answer, I wouldn't know it. Let's see. Where is this? Let me look through my notes. What did I call this? Math logical reasoning. Okay. Watch for proper mathematical notation, step-by-step derivations, handling of probability concepts, and practical applicability of the solution. Oh. All right. Famously known as the Monty Hall problem. Okay. They all say that. There are 3 doors, door 1, 2, and 3. Probability that the car is behind your chosen door is 1/3. Probability that the car is behind one of the other 2 doors, 2 or 3, is 2 over 3. Yeah. Okay. So I have no idea if this is true. Switching doors doubles your probability of winning from the car from 1 over 3 to 2. What? I don't know. Oh, stop using stars. Um, oh, because everything's spitting it out in Markdown, and anything that you should, if you're using a text-to-speech response, you should probably have a process in between that says convert Markdown to plain text. I think all these models spit out all of this is in Markdown. Which, yeah, switching doors is, so they all come up with the same answer. You should switch your doors. And every time I've seen this, I was like, how is this? How is this? How is this? How? How? I'm not that smart. I can't. I can't. I've seen it. I've watched people calculate it. I feel like I've seen like Veritasium or somebody else go through this exact problem. And I watch it, it's like, oh, okay, that makes sense. It's all clear now. But the video goes away, or maybe it was one red, two green, or whatever that channel is. One of them has shown it, and it made sense at the time, and now I no longer remember anything. Use latex notation. Oh, okay. Let's give that one a shot. Using, I can't copy. Copy text, okay. Let's paste this in. Okay. Using latex notation, please explain Newton's law of universal gravitation. 3 brown, 1 blue. Ooh, look at those pretty formulas. Here's the latex code. I know, I should be saying LaTeX, but I've been saying latex since I was in college in 88. So I'm stuck with saying latex. Sorry. Pretty equations. Cool. All right, let's see. What else we got? What else? Let's go to, oh yeah. Here was a kind of an interesting idea. So I'm going to take this bit of text from Plato's Republic. I'll start off with a new chat. And say, because it's English and Korean, translate this text into Korean. The beginning is the most important part of any work, especially in the case of a young and tender thing, for that is the time at which the character is being formed and the desired impression is more readily taken. And then I don't know where this came from, but I'm just going to press enter. And we get a bunch of answers. Now, I don't know about you, but I do not speak Korean. It looks like, just looking at it as if they are images, it looks like this one is very similar to this one. These two are very similar, but the others are not. But I do have a friend who does speak better Korean than I do. So I'm going to ask that friend, hey, friend, can you explain this to me? And that friend is Google Translate. So let's copy this. Oh, let's copy this. Oh, I can just copy. And paste this in to here. In all things, the beginning is the most important, especially for children, because that is when the personality is formed. I think that's right. Right? That is the time at which character is being formed and the desired impression is more readily taken. So I'd say that's pretty great. Let's try one of the others. This one. Oh, I need to. Okay, let's copy this one and paste it in here. Oh, did it do it? Let's clear this out and paste it in there. Okay, the beginning of a work is the most important part, especially for young and delicate works. I guess that's children. Young and delicate works. Because this is a time when character is being formed and it is easier to leave the desired impression. That's pretty cool. I mean, I'd say that both of those are good. I mean, to go to Korean and back in a different tool. Oh, I'd say that's a total win. What happens here, because we've got these two different ones? Paste this in. The beginning is the most important of any work, especially for something young and delicate. Oh, yeah, is it anything that's young and delicate, not specifically children? In the case of a young and tender. So this one talked about kids, but this one is talking about for something young and delicate. Okay, that's when character is formed. Although I guess they're talking about kids because you're not forming character in some inanimate, young and delicate inanimate object. So that would make sense. It's interesting. I mean, looking at these translations, I mean, these two look similar. It looks like there's a little bit of difference in here, but I see some of the same sets of characters in both of these. Of course, now I'm looking more closely. I see less of that. But anyway, I see some similarities. Actually, no, I see similarities between these two. But this is totally different. But I guess there's some similarities. Anyway, but it's interesting that they all kind of translated into roughly the same thing. This was always the doing translations was always I guess the most challenging class I ever had in college, because my degree is, so although I did a lot of computer science, I couldn't decide what my major was going to. In the US, you have a major and a minor, typically one of each, and I couldn't decide. So I have a minors in math, physics, and computer science, and then my major was in Russian language, and you could say that. I was thinking that the more challenging ones were Russian translation, but then again I failed. I got F's in a lot of my physics classes, but there was other stuff going on at the time. So anyway, play tic-tac-toe. Looks like I've changed to dark mode because it is dark outside. Okay, let's move my... I don't have enough room on my screen. Oh, I had another good one. How about this one? Convert this nested JSON structure into normalized CSV. The user is name, John, addresses, and then type home. Okay. I love that translation. That translation was fun. And while I'm waiting for that, let me see if there was another good one. There's another one about writing documentation. Yeah, here we go. Okay, let's see what this one does. Convert into nested. Okay. So it's come up with some more text that goes in there. Of course, we don't really have. It's interesting that it just, both of them made up. Oh, all three of them made up more of the addresses. It knew the kind of information we were looking for, so it made stuff up, which is good. Normalized CSV format. Username. Yeah. Okay, so it's figured out one is home, and that was in the source, wasn't it? I don't see it. But yeah, type home. And so it figured out there's a home address and there's a work address. And then we go through why it did all the things it did. Good stuff. There's one other one that I thought was kind of fun. Be in the right place. Okay, complete this API documentation. The authenticate method accepts 3 parameters. User token, which takes in a string. This is the user's authentication token. And then device ID. Oh, user token is a string, and device ID is a string. And then, what else should it take? So authenticate method takes 3 parameters. Here are 2 of them. What's the third? And complete this documentation. Well, that's pretty cool. Oh, it's churning stuff out. Okay. So authenticate method, parameters, user token, device ID, and device fingerprint. That explains all the possible outcomes. And then these other 2, what did they say? So we've got user token, device ID, and additional info. And this one is a timestamp. Additional info could be a timestamp, a device type, or security flags. So it could be all sorts of different things. Oh, interesting. Cool stuff. Okay, so who are you? Who trained you? And what were you trained on? And what were you trained on? Okay, I am ExaOne 3.5, developed by LG AI Research. My design integrates advanced deep learning techniques, primarily leveraging models from OpenAI and enhancements tailored by LG AI Research. Who trained me? Yeah. Oh, goes through a lot of detail. And then I am ExaOne, LG AI Research Director Kyung-Hoon Bai, trained on extensive text and code datasets up to April 2024. I'm ExaOne. Training was led by this guy. I was trained on a large dataset. Specific details are not publicly disclosed. My development. It's again, we see 32B is much more condensed, but we get a lot more juicy details on the 2.4 billion parameter model, and it just responds so much faster. So at first I'm thinking, well, maybe this is the 32 billion, and that was the 2.4. But the response tokens per second, 163 tokens per second on the smaller model, I would expect, this is 24 or 25 tokens per second. So that's definitely the bigger model. But the one that's spitting out the most information, now, is it helpful information? I don't know. Is it correct? I don't know about that either. But it seems to know who it is and what it did or how it got here. And it goes through a lot more interesting information. So that's pretty cool. And it responds super fast. Now, again, this is a H100. Each one of these models is using its own H100 dedicated GPU. I think that's how it's set up. When I was running my tests, I made sure I didn't really have to do anything to ensure that every model was being added to its own GPU. That is actually is different from how it was early on in Ollama's development. It used to be that if you had, when we first added being able to run multiple models, the first model would be spread across all 8, and the next model would be also a thin layer across all 8. And so having 2 GPUs of the same type would ensure that the model ran slower than having just one, assuming that it could all fit on one. But now, in some of my tests so far, when I load up any model, even a 70B model, it all goes onto one GPU, and then load up another model, and it all goes onto another GPU, and load up another model, it all goes onto another GPU. And so I saw that over and over, even with really small models that take up very little of the GPU, seems to be smarter and just the way you'd expect, rather than spreading itself out across all the GPUs and then run slower. So that was, when I saw that the other day, I was like, oh, finally. I mean, maybe this changed 6 months ago, but 7 months ago, that wasn't the case, or whatever it was. All right. I think that's all the things we should try. A lot of these things that I was playing around were kind of there's that classic. There are 3 killers in a room. Another killer enters the room and kills one of the first 3. How many living killers are left in the room? Something like that. That, who is it? Matt Berman loves to ask this question. Okay. Okay. The small one is just wrong. What? Wait, what? Okay. Did I say this right? 3 killers in a room. Another killer kills one of the first 3. How many living killers are left in the room? Initial setup. There are 3 killers in the room. Another person enters, kills one of the 3 initial killers. Let's note the killers. Killer 1, 2, 3. Total of it. New killer enters. 1, 2, 3, 4. New killer kills one of the 3. Killer 4 remains alive. One of the 3 initial killers is deceased. Therefore, there's only 1 living killer remaining. It was so great until the last sentence, and then it just messed up. All right, so let's go to the big one. Classic riddle that plays on how we interpret the situation. There are 3 killers in the room. Another killer enters the room, making the total number of killers 4. Perfect. Then this new killer then kills one of the original 3. Okay. Key point is the killer who enters and commits the act is still alive. Doesn't really matter. Therefore, after the killing, one of the original killers is dead. The 3 remaining original killers, minus the one who was killed, plus the new killer who entered the room equals 3 survivors, plus 1 new killer. So the number of living killers left in the room is 4. No. Let's break. Okay. 3 killers in the room. New entrant. There are now 4 killers. Perfect. New entrant kills one of the original killers. Okay. Suppose killer 4 kills killer 1. Specific of who was killed doesn't change. Who was killed the specifics don't change the final count. After the kill, killer 2 remains alive, killer 3 remains alive, killer 4 remains alive. Okay. So after the event, the number of living killers is killer 1, or killer 2, killer 3, killer 4. Therefore, there are 3 killers left in the room. And that is correct. So it was the one in the middle, 7.8, that got it right. Interesting. All right, so let's how many R's are there in the word refrigerator? How many R's are there? The word refrigerator. I would expect none of them to get this right, because I don't know if there's a way for them to figure this out. And how many are there? There are 1, 2, 3, 4. There are 4, right? R. So there are 4. So this one, the 32 says 3, which is wrong. This one says there are 2, which is wrong. And this one goes into a lot of detail saying that there are 6. And I could kind of see how this one happens. Okay, so, all right. If I can train through Collab, that's my plan. Oh, wait. Yeah. A local 2. Mostly what I'm interested in is using Axolotl or Auto Trainer for the fine tune, as I like both of them for training. My GPU can train it. Auto Trainer is easy to learn. Luna. Have you tried Unsloth? So I have tried Unsloth. I know you were asking Borch, but I have tried Unsloth. The problem with Unsloth is that there's all the documentation is done. Most of the documentation seems to be done through these Python notebooks, Jupyter notebooks. But there's enough places in the middle where they say like, okay, here are these 10 lines. This is what this first line means. This is what this 10th line means. Ignore the rest. Don't worry about all the magic stuff in the middle. It feels like, in fact, this came up pretty recently at home. The classic how to draw an owl image. Draw 2 circles. Now draw the rest of the fucking owl. That's like so many art books. In fact, my daughter, who is just turned 6 a few days ago, about a week ago, got a book of how to draw like everything, all the common things that kids want to draw, and all of them are like how to draw the owl. You know, like, okay, draw this circle, and now fill in all the rest. And I feel like that's the same thing with Unsloth. The documentation just doesn't document how things work. And there's enough places where errors do come up, but they don't explain what the errors are going to be. And if you get everything right, and you're doing exactly what's been documented in that, they don't do a good job of showing you, here's documentation. Now you have enough information to train any model that you're dealing with. And so you kind of have to keep going back to all these different notebooks that they keep producing. Whereas I feel like they could just write out some documentation that says, here's what this command line, here's what this line means, here's what this line means, here's what this means, here's what that means. And they don't do a great job of that. The one that MLX, anyway, that training, fine tuning, I felt almost it approaches it. I guess it does the same thing, but approaches it from a slightly different point of view, where they have all that stuff in the middle, but it's kind of hidden. You don't have to worry about it. You just run the command, and it does all the stuff in the middle without you seeing it. I don't know which one's better. On Mac, the MLX training, it worked really well. It was pretty fast. Yeah, it worked really well. Okay, so I'm at an hour and a half. My goodness. And of course, I'm recording the whole thing. I don't know if I mentioned this on the stream that I do with Ryan every Tuesday, but I'm recording this on a little who makes this? Atomos Ninja. It's an hour and a half. I see that I could continue recording for another 12 hours if we wanted to. I don't really want to. Yeah, I'd like to play around with axolotl, just because it's a cute little creature, and my daughter has now 2 stuffies that are axolotls, because apparently I saw some interview or heard some interview with like a company that makes stuffed animals, and for years and years, for decades, the most popular stuffed animals were always bears, teddy bears. Everybody wanted a teddy bear, but in the last like 5 years, the most popular stuffed animal is the axolotl, or at least in the top 5 or top 10 is the axolotl. Who'd have thunk? Let's see. Any other good ones? How about this one? Given these symptoms, frequent headaches, blurred vision, high blood pressure, discuss possible diagnosis and needed tests. And then we'll stop. Spitting the stuff out. All right. Given the symptoms, there are several potential underlying causes that warrant careful evaluation. Possible diagnosis: hypertension, high blood pressure, frequent headaches, particularly elevated blood pressure can damage blood vessels. Okay, or orthographic migraine. An orthographic migraine. Okay. Meningitis. Well, that doesn't sound good. Fever, stiff neck, altered mental status. Optic neuritis. That sounds worse. I don't know. Meningitis, optic neuritis. Sounds, and chronic stress. Okay, stress sounds less bad. Me speaking as a non-doctor. Recommended tests: blood pressure monitoring, vision examination, blood tests. Wait, didn't we say blood tests? Oh, blood pressure monitoring. Imaging studies, MRI of the brain, and a retinal ultrasound. I saw that as rectal ultrasound. What's that? I can imagine. Next steps: schedule an appointment with neurologists or ophthalmologists who can conduct a thorough evaluation. Okay, good. And then the 32, hypertension, we saw that. cerebrovascular issues. Some migraine. Okay. Glaucoma. Okay. Optical neuritis. Diabetic retinopathy. Brain tumors. Intracranial hypertension. Recommended tests. Ambulatory blood pressure monitoring. Okay. Ophthalmologic evaluation. Okay. So I felt like I saw more specific I wonder if these columns are not, if we're, let's see, they are about equal, but I wonder if there's something around the spacing that makes, how wide is this? I'm using my fingers like this on the screen. Very scientific. No, it looks like the text is about the same width. So they are, okay. But I felt like the 32B model gave more specific details on, so what do you recommend for a straightforward, easy to use agent framework? I think that question came up at the beginning. I don't. Not that I don't like it. I don't have any specific recommendations around an agent framework. All I know is that I use Crew AI early on. I have a video about it, basically saying Crew AI is stupid and you shouldn't be using it because it doesn't really offer anything beyond what you can just do with Ollama without Crew. But that was a few months ago, and it was pretty early on in Crew AI's lifetime. So maybe things are better. Llama Index has something. LangChain has something. There are lots of other tools that have something. I have no answers. I have no answers. Wow, there have been a lot of people asking questions. This is great. And so we're coming up to 1 hour and 40 minutes. Oh, I thought I heard the garage door open. Ooh. How about this one? It's an interesting question. Translate this idiomatic expression into 3 languages. We know it knows about Korean and English. What else does it know about? It's raining cats and dogs. Explain cultural equivalence and meaning preservation. That's pretty cool. Okay, and it translates into... Okay. In English, the translation is into Spanish. Originates from 12th Night. But it's translating each time into Spanish. Anyway, and then Japanese. Cats and dogs are falling down. Anyway. French. Translation into French is that translates to "it's raining ropes," which similarly uses hyperbole to describe very heavy rain. Huh. LangGraph is good too. You just need DB interaction. With MongoDB, create patterns for conversation. I'm going backwards. Create a knowledge base with Ollama model. Then you can add your own fine-tune, plus you can attach YOLO or Whisper or TTS. So I have strong opinions on tool calling. Basically, there are two ways of doing tool calling. There is the way that Ollama added a year and a bit ago, and then there's the way that Ollama added 6 months ago, or yeah, probably 4 months ago. The one that's added more recently is more more easily replicable, but less effective than the older method. The older method was more effective, but felt kludgier. Do you want something that feels less kludgy but is less effective, or do you just care about what's most effective? Yeah. Well, my wife just got home, so that means my daughter's home, and we're gonna probably get ready for dinner. So I should probably go. I've been going on for an hour and 45 minutes. Thank you all so much for being here. It was great. I see there's still 20 of you here. So yeah, I'm gonna leave. Thank you again. Was this interesting? Was this an interesting use of time? Is it interesting for us to go through each of the models? You know, because there's a lot of models to go through. I mean, Ollama dot. If we look at what's newest, so ExaOne, there's Llama 3.3 just a little bit ago. We can look at different embedding models as well. But Sailor 2, QWQ, specifically around reasoning, Marco 01, which looks pretty cool, Tulu. In fact, I looked at these pretty recently. I was like, whoa, who's Marco? Who's Tulu? Who's Athene? All these are 59,000 pulls, 259,000 pulls of Llama 3.2 Vision. So it looks like some really neat things that are out there. Llama 3.3, 265,000 pulls. Yeah, so I had fun. I'd like to do this more often. I'll probably take today's stream, edit down all the useless just sitting and waiting. And we didn't do too much of that, but there's some. And make that into a more polished video that gets posted hopefully tomorrow. And that'll be my Tuesday course video. And Paga YouTube Premium. Okay. I don't know what that means. Garcito Chelito. Okay. I think having YouTube Premium is definitely a good thing. That way you avoid all those ads. Because ads, I mean, I love them. I hate them. I don't know what to. All right, so I'm going to switch over to me. Your videos help me so much. Thank you. Oh, well, thank you, Will Dev. Really good stream, Matt. Thank you, Matthias, Luna. Marco is synthetic data. Oh, Marco is synthetic data. Web UI is great. Love the examples. A lot of people could use help just finding links. Like, where's the documentation for this and this? Like the Ollama API docs. Yep. Ollama API docs. Very thankful for you and all your content from Daniel. I hope you're doing well. Daniel, you look just like Coach. What's his name? Coach. What's that show? What's that show called? The English football show. I realize it's probably just you've taken this screenshot from there. Because maybe Borch doesn't really look like that either. Okay, 5.4 is finally out. I was the one announcing 5.4, says Stanley. Yes. Do we have anything? Doesn't look like 5.4 is Coach Lasso. Yes, Coach Lasso. Thank you. I am. Oh, I'm from Kansas, and my parents grew up with Jason, the guy who played Ted. Huh. Your parents, it sounds like your parents are my age. So you are a child. No, you're younger. That's great. Yeah, that was one of the things with when I was working at Datadog. You know, I was the first evangelist at Datadog. Started when we were 15 years ago. Was it 15? 14 years ago? Um, and so I mean, Datadog was 30 people at the time. But later on, as the company grew, I was always based in Boston, and Boston was the sales office, and the sales office was filled with all these 20, 20-year-old, 20 to 22-year-old, 23-year-old kids. and every now and then, you know, my age would come out. It says, "You're the same age as my grandpa." It's like, oh, dude. Oh, come on. So yeah. All right. So it'll be released this week. Cool. Love the dog. Love the dog. Jade, somebody somehow saw you. Come here. Come here. Let's get on this. Let's just get on the screen. All right. Oh, here's the doggy. Hello. Wave hi. Hi. That's Jade, our little pain in the ass. Yes. Ugh. With age comes wisdom. Sure. I was too dumb to get a job at Datadog. Yes. I So at Datadog, I if you had a referral for a non-sales kind of position, and that person got hired and stayed for 6 months, then the person who did the referral got $5,000. But for a tech role, it was $10,000. So if you referred all your friends, you could get $10,000 for each one of those people that stays on. Um, so there were some people that got like 10 of their friends to start within 1 year, and so they got this check for, well, added to their paycheck, but an extra $100,000 minus taxes, but $100,000 that they got in referrals. Amazing. I know there's one of the women had like 10 people who got hired, and I kept trying. I would find these great people. I knew of these great people, and I like refer them, and they never got past that initial phone screen. It's like, oh man, these people are awesome. How come they don't? I mean, it's not just about the money, but I would have really liked that money, and I never got it. I never got a single person to go through the full referral process. 10 grand. 10 grand. I mean, that's not unusual for a lot of tech companies. I'm sure it's probably more now for a lot of tech companies. If you do the referral and you get 10, 15, maybe even 20,000 now. Never did. Never got it. Okay. All right. Let's see what else. Yeah. So this looked pretty good. Thanks so much. I'm already now at an hour and 50 minutes. This is like the hardest part of these streams is saying goodbye and actually clicking on the button that says goodbye. Oh, I'm looking at these models and you're not looking at them with me. Yeah. So we kind of look through. There's a whole bunch. Yeah. It looks that. There's a whole bunch of here that I haven't really spent much time with, and so it'd be great to go through them with all of you. And so maybe we could do that together more often. Thanks so much for being here. Again, I said that 4 or 5 times already. I'm going to go away now, and I'm going to stop this recording. I'm going to stop you, too. Bye. Let's click on finish. All right, bye. I thought that would stop. Okay, bye.